Okay, so we have to write them in scientific notation, and the first thing I've always told you to do is basically go fishing, find the first number is not 0 and the last number is not 0, throw it out, in this case it's a 7, and then always write times 10. Now, since this number is bigger than 0, all we've got to do is come up with a positive exponent and see how many spots we need to move it. And in this case, we're counting up the places, not the zeros, the places, and that would be 4. So it's 7 times 10 to the 4th. Down here, number 2, do the exact same thing. Our first number is not 0, is 8, and the last one is a 3. Throw it out here. Write your 83. Always put your decimal right there behind the first number, right there, times 10. Now in this case, this whole number is less than 1, so now we just have to move this decimal to where we need it to be, right there behind the 8, and count up our place values. 1, 2, 3, 4, 5, 6. So we moved it 6 times, but this number is less than 1, so it's a negative 6. And let's go through and do this one right here. There we go. It's 3.8 times 10. Again, this number is less than 1 because we've got that decimal spot right there. So it's going to be a negative, and we would have to slide it over 1 spot. So it would be to the negative first power. So there we have it. We've converted those standard form numbers to scientific notation. Now we have to go exactly the other way. Right here, you'll see that this is a negative exponent. So that means here's your front number. There's the 8. So you write it right there. Your decimal is waiting right here, and because this is a negative exponent, we've got to go this way to make it less than 1. So when I move it in front of the 8, that's 1 spot, and now we've still got to go 5 more places. So there you go. This time, it is a positive exponent. So when I write my front number of a 3, I'd have to go this way to make it bigger than a 1. It's a positive exponent, so my final number has to be bigger than 1. So I'd actually have to add on 5 zeros right there, so it'd be 300,000. Number 6, the key here is that you must look at your exponents. When you're adding or subtracting, look at your exponents first. They have to be the same. Once they're the same, it's very easy to just add up the front numbers there. So this 2.1 I'm just dropping right there, and this would become 8.5, and then keep your exponents, those powers of 10s, exactly the same. So 8.5 times 10 to the 4th. What happens when they're not the same? Well, you go to the smaller exponent and you add on what you need to. We need to add 2 to the 5 to make it this. But once you add on 2, you've got to move this decimal back 2 spots. So this would become 0.022 times 10 to the 7th. So that's how we can adjust this. And now we can add the 0.022 to this right here, and we get 5.822. And now we can just leave it as times 10 to the 7th power. Make this 8 into a 9 by adding 1 to it, which means we slide this back just once. However many times you add to the exponent, that's how many times you slide it back. So this will become 0.824, and that lets us be able to set this up for the addition right here. The 0.824 is added to it. So it looks like it's 7.984 times 10 to the 9th power. There we go, almost done. I think we've got about 5 more to go. 2 more, that's addition and subtraction. So this one's subtraction. We absolutely have to make this one the same exponent. So this is going to slide back once, and this becomes 0.521 times 10 to the 4th. Now, what you see that I've done over here is I've taken the front numbers and I've stacked them on top of each other so we can do the subtraction. Add in the zeros as needed, borrow, and you'll be all set. And it would be a shame that after you take care of all of this that you forget to put on here times 10 to the 4th power. Okay? So let's look down here at this last one right here. You'll see that these two are the same. So we can go ahead and add the 8.2 and the 1.8. And what happens here, it's really, really important that we see this. What happens here is that we got 10. So it would be 10 times 10 to the 20th, but the problem is we can't have a front number that's double digits. 10 is too big. So what we have to do is we have to literally take the decimal and slide it back at least one spot to make it 1.0, okay? But because I slid that back once, we're going to have to add 1 to the exponent. So it'd be 10 to the 21st power. So there's your final answer, 1 times 10 to the 21st power. Multiplication's pretty straightforward. We're just going to multiply the front numbers here. In fact, I'm going to put parentheses around the two scientific notations. So 6.2 times 5 is equal to 31 exactly. Add your exponents in this case. So that would be 10 to the negative 4th power. The problem is front number is too big, just like in the last problem, so it should be 3.1 times, since we slid this back once, we're going to add 1 to the power there, to the negative 3rd power. So 2 times 4.73, so we're going to multiply these front numbers right here, is 9.46. So that's good, it's not over 10. Times 10 to the, add your exponents, be to the 4th power, and we're done. Everything checks out there. Last one's right here, 5.8 times 5. And you'll see that we get 29, and so I know I'm going to have to adjust that, but I want to go ahead and work with this. Add 6 and negative 5, we would get 10 to the 1st power. So because this front number is too big, slide this back once, add 1 to it, and we would get 2.9 times 10 to the 2nd power. So hopefully seeing these problems worked out will help you bring it back to your memory. If not, go back and watch the actual lessons where I get into better explanations.